Okay, suppose we have a triangle here. We call it triangle A, B, C, and we have these three vertices. A is at 410, B is at 0, 0, and right now C is at 10.66, 1.54. But we can move C around and change the size and shape of our triangle. So let's take a look at a couple aspects of this triangle. So for the first thing, we have three sides, these three segments here. We have segment A, which is opposite vertex A. We have segment B, which is opposite vertex B, and we have segment C, which is opposite vertex C. Okay, let's look first at the midpoints of each of our three sides. So in each case, we found the midpoint of the side, and to do it, we found the point that is halfway between vertex A and vertex C in this case, which is point E. The calculation that we do in order to find the x and y coordinates of point E is we just take the averages of the x coordinates of point A and point C. So we have 4 plus 10 over 2. So that gives us our x coordinate of point E, which is 7. We then take the y coordinates, so 10 for point A and 4 for point C. We add those together and divide by 2 to get their average, and again we get a value of 7. So E has coordinates of 7, 7. So even as we move point C around, we can see that our calculation of the coordinates of E is just staying the same. The x coordinate of A plus the x coordinate of C, 4 plus 6 divided by 2, which gives us 5, our x coordinate for E. And then our y coordinates for A, 10, and our y coordinate for C, 6, are added and divided by 2. And that gives us 8, which is the y coordinate of point E. And that process is the same for each of the other three midpoints. So we have these midpoints, and obviously as we change the triangle, those midpoints are going to change. Okay, so let's take a look now at the medians. The medians are segments that are drawn from each vertex to the midpoint of the opposite side. So we have the median that goes from point A, one of the vertices of the triangle, to point F, which is the midpoint of the opposite side. And we have that for point B and for point C, so we have three medians. And notice that our medians are what we call concurrent, which means that they all meet at the same place inside this triangle. So this one point right here is the point where all three medians meet. And this remains true even as I move point C around and change the size and shape of our triangle. Those medians always meet at a single point, and that point is always inside the triangle. Okay, let's take a look at our altitudes. The altitudes are the segments that are drawn from each vertex, so from vertex A to the opposite side, which is side BC, such that this segment that we draw is perpendicular to the opposite side. So in other words, segment AI is perpendicular to segment BC. So what that means is that where this segment intersects side BC, it's not going to be at the midpoint. It could be, but it's certainly not necessarily going to be at the midpoint. And as we change the shape of the triangle, we can see that where those altitudes meet is going to move around. And in fact, when this triangle becomes a right triangle, and we can see that because of this right angle marker here, with C as the right angle, that our altitude from A to side BC is in fact just the leg of this triangle, or one of the legs. And our altitude from B to side AC is also a leg. And so our three altitudes then meet at point C, which is the vertex where we have the right angle. Now, when we move point C such that our triangle is no longer a right triangle, and in fact it's now an obtuse triangle, where our largest angle, which is the angle at point C here, where the largest angle has a measure greater than 90 degrees, our altitudes are no longer inside the triangle for two of the three sides. So the only one that's still inside is the one that goes from the obtuse angle, the angle greater than 90 degrees, to the opposite side. The other two altitudes don't meet the opposite side inside the triangle, so you have to extend the opposite side. So for point A, the opposite side of the triangle is this side labeled lowercase a here that goes from B to C. But in order for the altitude to meet that, we have to extend the line that runs through BC and bring it all the way out here to point I so that the altitude from A can intersect this line that connects points B and C. So our altitudes will in fact meet. It's not showing that. If we extended them, then AI, HG, and BG would all meet somewhere maybe out here. But they would meet outside the triangle. And that happens when we have an obtuse triangle with one angle greater than 90 degrees. Again, when the angle is 90 degrees, they meet right at that vertex where the right angle is located. And then when it's an acute triangle with all angles having measures less than 90 degrees, our altitudes meet inside the triangle. Okay, we also have what are called the perpendicular bisectors. So our altitudes, as we saw, went from a vertex but did not necessarily connect to the midpoint of the opposite side. So clearly point I here is not the midpoint of side BC. When we look, however, at our perpendicular bisectors, the way those work is we find the midpoints of each of the three sides, and we draw the line that is perpendicular to that side but passes through the midpoint of the side. So we look at side AC here, and its midpoint is at E, and we draw the line that is perpendicular to AC but that passes through its midpoint at E here. And again, we can see that these three perpendicular bisectors are concurrent. And by that, we mean that they all meet at a single point. Now, when we have an acute triangle, as we have here, where all angles have measures less than 90 degrees, our perpendicular bisectors, again, meet inside the triangle, as we can see. However, when we make our triangle such that it has a right angle, as we have now at C, then our perpendicular bisectors meet somewhere along the hypotenuse of this right triangle. And when we keep going and make the triangle such that its largest angle is greater than 90 degrees, or in other words, it is an obtuse triangle, then our not our altitudes, but our perpendicular bisectors meet outside the triangle, and we can see that point of intersection right here. Okay, so one of the other things that we can look at is the Pythagorean theorem, where we look at, in this case, we'll say that C is our hypotenuse, and we'll say that A and B are two legs. So when we have an acute triangle, all angles less than 90 degrees, A squared plus B squared is greater than C squared. We have 10.77 squared, which is A squared, plus 8.49 squared, which is B squared, is greater than 10.77 squared. And in fact, our triangle is currently an isosceles triangle. So with sides lowercase c and lowercase a having the same length. Okay, so let's make our triangle a right triangle. Now we can see that a squared plus b squared, 7.62 squared plus 7.62 squared, is equal to the third side squared, 10.77 squared. We can make a different right triangle here. And again, we see that a squared, or 4 squared, plus b squared, which is 10 squared, is equal to c squared, which is 10.77 squared. Okay, so here when we have an acute triangle, a squared plus b squared is greater than c squared. When we have a right triangle, a squared plus b squared is equal to c squared. And when our triangle is obtuse, we can see that a squared plus b squared is less than c squared. And that's the case right here, where we have a is 5.83, b is 5.1, but a squared plus b squared is less than our hypotenuse squared. And again, we're calling our hypotenuse the segment that connects A and B. And it's somewhat arbitrary which one we call the hypothesis, or the hypotenuse, but it worked better in this case. Okay. The other thing we want to look at is, suppose that we show all of our medians, altitudes, and perpendicular bisectors at the same time. Well, they're sort of all over the place, and we can influence where they are by moving point C. We can see that when C falls somewhere along this purple line, that our purple and red lines start to coincide more, or at least to some extent. And in fact, we can get all of our segments to correspond. And we can do that by making this an equilateral triangle. And when we click this here, you can see now that all of our sides, all of our medians, all of our altitudes, and all of our perpendicular bisectors now coincide. And that's a feature of an equilateral triangle. As I move point C, we can see that's no longer going to be the case. If I move point C along this purple line, which means that the triangle remains an isosceles triangle, we can see that some of the lines coincide, but certainly by no means do all of them coincide.